Right, so one of my favourite sets, the Amstrad 900, not the 901. Because we can just forget that there's any fake or dodgy or cheap ones out there, because the Amstrad 900, always made in Japan by Cybernet, and so you know what you're getting. And what you don't get is the PA, the Channel 9 switch, and the Roger bleed. Isn't that lovely? Good, suits me. So they're really good sets, except this one has got distorted audio on receive. So again, it's from the same Sheffield dealer. He's changed the audio, I've seen one or two other things, and he's got a bit stuck with it, so would I have a look at it? Yes. Put the soldering iron on ready, I'm bound to need that. He's got the early type of plug which we never seem to be able to, well, we've not been able to get them for 40 years. You can put a Cybernet one in the wrong, but you've got to be very aware of polarity, because it will go either way round. I've got a little stub on here for Cybernet, but it's a bit dangerous, especially for clumsy people who'll get polarity wrong. Right, so we'll power it up, 13.8 volts, switch on. Just hope there's something really silly, because we can all overlook things, but it can also be something faulty, of course. And we've got one other from this gentleman, and that's a Fidelity 2000, so it's a Cybernet 134. So put picture in picture on, and let's see what it's doing on transmit. Doing 4 watts. For the sake of argument, we'll look at deviation. Wallow. It says 1.5 on there, but he's probably lying. Let's see what that sounds like on our monitor receiver. I know it's close quarters, but we'll give it a go. 1 2 1 2, testing 1 2 3 4 5 5 4 3 2 1 1 2. So that sounds fine. We'll talk back to the radio actually. 1 2 3 4 5. Put an extension speaker in. Turn the squelch down. I've got nothing. Testing 1 2 3 4 5 5 4 3 2 1. 1 2 3 4 5 5 4 3 2 1. 1 2 3 4 5 5 4 3 2 1. Well, I'm going to have to do something about the squelch not coming through, aren't I? So it's the only thing that lets down this chassis. So we'll look at transmit later, because I'm sure it's spot on, but I will be going through it. He's done the ballast resistor there for a type which will deliver 4 watts. So we'll put 2779125 into our signal generator. Let's put that up on this inset picture. Right, we'll swap it over to the test equipment input rather than the speaker mounted on the wall. Now we can see what we're looking at, hopefully. That doesn't look bad. Let's go over to the oscilloscope. I'm going to look at the cyanide meter. Well, I'll tell you what we need to address is why the squelch is on all the time. I can't remember whether it's that or that one for squelch. Clearly that one. Biggest signal on for that. It's about there. So we're there at about 12 dB. I've not done it before on this. 0.46. No, we haven't got 0.51. That was 0.46. Just about doing 1.3. Put an S9 signal on it, just bring the meter up. Plus 30, plus 30. Well, to be honest, it doesn't sound distorted to me. It doesn't look distorted on the oscilloscope. Let's go back to the oscilloscope. Let's go back to the oscilloscope. Certainly seen a lot worse. Let's put a different tone on it. Perhaps it's awful if we do 440 Hertz, for example. What have we got? Internal signal generator. That's 440. fine. Let's go back to 1 kilohertz. I don't know. I've retuned that. Have we got rid of the snag? Have we not got rid of the snag? I don't know. And it's alright listening to the breakers out there, but you know, a lot of them are off frequency and using illegal radios, so it's hard to tell. Right, I'll go through this transmitter. Again, I'm not going to, I don't really need to note down what it was. Of course, you'll have got it right anyway. So it's doing 4 watts. Let's go to the main meter. But he hasn't sent it me for a laugh either. So, got that right on the peak. That's VCO. Right on the peak. Peak. Wants a bit more heat. Still wants more heat. That's fine. And it's already doing 4 watts, so that's also fine. So let's look at the other channels. 4 watts. 4.05. Low power. 250 milliwatts. Transmit current. Ooh, 1.5 amps. VCO. So we want channel 40. Wonder if he's changed that filter. So we should have, yeah, we've got 3.6 volts on receive, 3.7 on transmit. Let's go to channel 1, 1.9 something, 1.9 something, that's fine. Back to channel 20. Just going to adjust the meter. have a look at the under. I'll take that away. No, I mean, all I can say is I've retuned the receiver. Sounds fine. Right, we'll go over to the speaker on the wall and see if we can hear anybody on it. Take it off the signal generator. I tell you what, before we do that, we'll just check the deviation with the test set behind me. We're on channel 20. Wow, spot on. Right, we'll plug our Antron 99 in. Roger. All I can do is leave it on and come back to it. It just could have been one of these IF ones slightly out, or it could be something that develops, but he's done a lot of work to try and sort it. The danger is he may be talking to a specific person who isn't 100% right. I don't know. It's a difficult one. Squelch to full. So on the test set, once again that's set right. And it doesn't always hiss when it's got no signal. Now that isn't necessarily a snag. Put it on the aerial. It'd be nice if we could hear somebody, but we can't. Squelch on. Yeah, that's squelching out now. Have I recalibrated that S meter correctly? Because it seems to be lighting up all the lights without there being much signal. I want that to be plus 30. There we go. S9 is 100. Right. I'll also check for a loose aerial socket on this one like we've had recently. Just make sure I can put that precision screwdriver in. Like that. Plug the aerial back in. What nano, Roger? Well, it'd be nice if there was somebody on. Let's just once again try it with our handheld. Testing 1 2, testing 1 2 3 4 5 5 4. No distortion there. Oh well, that didn't work out, and he's already done the capacitors. Fiddling with those adjustments, we'll just see whether that improves it. I think we're going to be doing Scratchy Corner, and I think that's going to be the first live person we're going to hear on it. So what I've decided to do, comparing between my set and the customer's set, this definitely sounds a bit bassier. It's not any difference in the distortion, but it sounds a bit bassier. And I'm just wondering if the capacitor, where's the circuit diagram? I'm just wondering if the capacitor's seen better days. So, tone control is there. And all it is, you're putting a 47 nanofarad capacitor in. It's a cheap disc ceramic one, 4p value. So we're putting a really expensive one in, just in case. I don't think the set's faulty. It's just, there's no two ways about it. The receiver isn't as sensitive on the customer's set as it is on ours, but it's still well within what the manufacturer says. So it is exceeding the specification, but not as well as ours. Now, conversely, our set's only putting out 2.5 watts, but that's because it's got the 2.5 watt ballast resistors which need changing. But we'll do that on a subsequent thing. So I'm going to have a bit of a faff here, because to get to this, I really need to pop these controls out. So that's what I'm going to do. So as you can see, getting those two controls out, we've got this capacitor here, which is just between these two controls. So it's 473, 47,000 picofarads, which is exactly what we have got here, 47 nanofarads. Is that right? Checks with the circuit again. Yeah, it says 47 nanofarads. Right, so get that unsoldered. Hoping just be able to pull that out. It's probably J-hooked to cut one end off. I'm going to spray that because it's a bit, it seemed a bit noisy. So whilst we've got that out, I may as well do that. Have I got a suitable tester on here? Not sure that I have. No. just thread that around, which is how the other one was. Spray that one as well at the same time. And hopefully we'll get those two back in. It's so much easier in the long run just popping them out like this than to try and solder down the gap. Trying to get it to locate in its little slot. Right, so we'll turn that back on. I need to plug the mic in, won't I? Talk to myself. I'm good at doing that. 1, 2, 3, 4. I'm on the wrong channel, aren't I? Tango 21 testing. 1, 2, 3, 4, 5, 5, 4, 3, 2, 1. 1, 2, 3, 4, 5. Well, I think that's the best thing we can do with that. You know, what other capacitors? If the dealers put all the right capacitors in, I mean that is something we could check because there would be a tone difference if it got something wrong. But I doubt he would. $47. It's like 33. We've got 3.3. Let's just see if I'm right. Capacitor 100. Yeah, it's 3.3. Right, I will put the front back on this. It's lost its tabs over the years. Try and get all these on in the right place. Right, there we go. But I can hear a definite difference now. I was struggling to hear a difference between before. So let's see if we can put it on the air, see if anybody's talking out there. Roger. Now there was a possibility when I did the cyanide reading that the RF gain wasn't at full. I'm just going to recheck that and then we'll call it a day. Yeah, that's better. 0.28. So that's 0.28 for 10. Oh, I've got to change the frequency. What a twit. Check the frequency of the radio. Yep. So for 10 dB, let's go back to where we started. 12 dB, I've actually now got 0.25. Keep altering this, don't I? For 10 dB, 0.22. And for 20, it's 0.65. And now this let's put it to 12 and you'll see as I alter the tone control how it is affected. There you go. 100 microvolts. Excellent. We've already done an on-the-air test with this. I just wanted to make sure it was really good. But unfortunately there's nobody on to kind of compare with it on the aerial. Right. Well, we got there in the end, and yeah, it's just a bit bassier than my sample, but I'm assuming that the distortion disappeared in the retune. Thanks for watching.